My fabulous earth science faithful, trying to work on this new way to make videos and to make sure everything's you can see it. Just notice I moved that video of me up. Hopefully the bottom is not going to come into issue. I'm going to try to upload these to YouTube so that when I send them out to you, you can see them better. Okay, so here we go. How can scientists infer the properties of the Earth's interior? This should be page 15 in your notes packet. And we're going to get to this picture in just a second. You're going to have to label it up a little bit. These are what you're going to end up labeling it, but this is why we know what's going on. The properties of the Earth's interior are inferred by observing earthquake waves. So here it says, in Earth's interior by. So observing earthquake waves is what you need to write. Okay, what is the focus? Well, the focus is the inside point of the Earth where the earthquake originates. So notice that on the top of the picture, it says earthquake focus. So next to focus, you need to write the point inside the Earth where the earthquake originates. And we're going to move on to epicenter. But here's a pointing to you where the earthquake focus is. Now on to epicenter. This is the point on the Earth's surface where the earthquake occurred. So this is directly above the focus. So this is a lot like lava and magma, right? Magma is lava that's underneath the Earth's surface. Lava is magma that's come up. They're the same thing, just depending on are they on the surface or not. So same thing here, right? This is the part on top. This is the epicenter, is the part on top. That'd be this part where those all three rings connected. So next is this picture. How do we know that the Earth's inner core is solid? And it has to do with these waves. Okay, so here's where you got to label up the picture. The top part of the picture you need to label as the earthquake focus. Then on either side, I have P and S waves are being received. Then in the in the bottom parts, only P waves are received. We're going to find out why. And the shadow zone is where no waves were received. Okay, and that's because there was a liquid core there. The inner core is solid, the outer core is liquid. And this is how we know, because this is a neat little graphic that shows you what's going on. So we're just going to let this thing play, and you can see what happens when the earthquake happens, what happens to the waves. When they hit the outer core liquid, they don't go through good until they get back into the inner core, and they can get through a little bit there. It's kind of weird, right? But that's what's going on. We know the inner core is solid because of the refraction or bending of the P waves. So there's no actual place to put that. So this is where I would, on the left-hand side, where you have a little bit more room to write a little note. We know the inner core is solid because of the refraction or bending of the P waves. We have enough room for that on the side left margin. And then what are the types of earthquake waves and how do they travel? This is this next P wave, S wave box at the bottom. And these are spring coils, which is much like a P wave. So some things we remember about P waves. They're technically called primary waves or push-pull waves. So they're like this. Pop, 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 pop. They power through anything. So you need to put that in there. That means they go through solid and through liquid. Okay. Power through anything means they go through solid and liquid. You might want to write that instead of power through anything. They go through solid and liquid. Because then S waves don't. S waves are more like this. These are secondary waves, or called shear waves. And notice the picture of them different. It's more like an actual amplitude wave, right? These go through solid only. Okay. Oops. So then there is a video that I'm going to try to record into this about what happens in an earthquake in Nepal. See what happens. Okay, this thing goes on for another 8 minutes, and the music's terrible. And this is the most graphic of the videos, so I'm going to leave it at that. If you really want to watch the whole thing, I can get you the link to the whole thing. Okay, moving on to page 16. Important features. Earthquakes occur mostly at plate boundaries. They can be man-made, so that happens as a result of fracking. How do you stay safe? You want to protect yourself from falling debris, so protect your head. Get under a desk or table. Stand in a doorway or along an inside wall. Stay away from windows because glass breaks. To minimize damages and economic loss, this is where we strengthen building codes, which just means we build the structures in such a way that, like when the earthquake hit Haiti, right? I think that's the right one. The destruction was massive. Well, they didn't have a lot of code in how to build their buildings, so they need to be reinforced in such a way that they can withstand an earthquake. Okay, reinforcing the walls helps. Richter scale. This measures the amplitude of the ground motion. Base 10 increase of magnitude. So a 1M earthquake is 6 ounces, where an 8 is 6 million tons of TNT. That's magnitude. The M. I don't even know how to say this, but you need to be able to write this. This is based on observations of those who experienced the earthquake, includes levels of damage and instructions. So this is one I don't hear about. This wasn't one they put on the news a lot, but it looks like this. And this is just writing your notes. There's really nothing to write here. But you can see that the Richter scale is in here. So that's what I like about it. And then you can read like a magnitude 6 on the Richter scale is a 7 on the Mercalli scale. Little damage in specialty built structures, considerable damage to ordinary buildings, severe damage to poorly built buildings. Okay. And a tsunami is a large wave caused by any undersea earthquake or landslide. It makes a large displacement of water. So let's watch this YouTube video and I'll give you an idea of what a tsunami is.
跑！赶紧跑！要冲下去了！我这就是控制。拍不上来吗？肯定拍上来，别急。
All right, so I'm not going to play that whole video too. If you guys want to see these videos, I can put the links up and you can watch them, or you can just Google them right quick and check them out. But I'm not going to put it all in this video. Okay, so now you know what a tsunami is. And so from here, we're going to go to the video called Tsunami and watch it and answer your questions on page 17.